let us study what's meant by significant figures or significant digits. Okay, so first let's see this definition here. It is defined as a number of meaningful digits which contain numbers that are known reliably and the first uncertain number. For that we'll see an example, then we'll go to the definition here. Okay, so let's take a stick here. Okay, the length of stick is measured by 3 people. Okay, so first one person gets 7.20 centimeters, second person gets 7.22 centimeters, third person gets 7.23 centimeters. You can see that the first two digits, okay, they are accurate, they are precise. Okay, so we can say this number 7 and 2, it's common there. Okay, these numbers are repeating, we say that is reliable. Okay, that means we can trust it. Okay, but you see the third digit, this one, okay, 0, 2, then we get 3. Okay, this is we say uncertain number. Okay, so this is an uncertain number. Okay, so now we'll go to this one, significant digits. Okay, what's the meaning here? It is defined as a number of meaningful digits which contain numbers that are known reliably and the first uncertain number. So you can see that we know these two numbers are reliable and this is the first uncertain number. Okay, so we can say that in this thing, the significant digits for these three numbers, okay, that is 1, 2 and 3, okay, because 2 reliable and 1 certain. So number of significant digits is, in this case it is 3. Okay, significant digits is 3. Okay, next we'll study what are the rules to find the significant digits. Okay, let us now study the rules for counting significant digits. Okay, so rule and the example is there. All the non-zero digits are significant. That's the first point. So now you see 1342, okay, has 4 significant figures. Why? Because we have this 4 numbers. Okay, 1342, they are not 0. Okay, so that's the first rule. All non-zero digits are significant. Second one, all zeros between two non-zero digits are significant. Okay, now you see 2008 has 4 significant figures. Okay, you see that. Why? Because okay, these zeros are there now. Okay, they are between two non-zero digits. Okay, they are between two non-zero digits, so we can say they are significant also. Okay, now let's see, go to third point here. All the zeros to the right of a non-zero digit but to the left of decimal point are significant. Okay, so this one. So third point, so you see that now, so 30700 has 5 significant figures. Okay, why? Because you can see that the rule is that all the zeros to the right of a non-zero digit. Okay, so this 3 is non-zero. Okay, and this 0. Okay, and see now after 7. Okay, after 7 we have 2 zeros now. Okay, are these 2 zeros significant or non-significant? That you must know. But you have, there's a decimal point here. Okay, because the decimal point is there, we have 5 digits here. Okay, so let's count and see. 1, 2, 3, 4, 5. It has 5 significant digits. Okay, I'll draw it more darker here. 1, 2, 3, 4 and 5. 5 significant digits are there. Now let's go to fourth one. For the number without a decimal point, the terminal or trailing zeros are not significant. Okay, so for number without decimal point. Okay, so now you see 30700, okay, has 3 significant digits. Okay, why? Because it doesn't have decimal point. Okay, so you have only 3, 0 and 7. Those are the 3 significant digits. Okay, now next one, B part, in that all zeros are significant if they come from a measurement. Okay, now you see here 30700 meters has 5 significant figures. Why? Because it comes from a measurement there. Okay, now fifth point there, if the number is less than 1, the zeros on the right of the decimal point but to the left of the first non-zero digits are not significant. Okay, now see this number 0.00345 has 3 significant figures. Why? Because you can see this rule here, this number is less than 1. Okay, and they say that the number on the right of decimal point. Okay, so this number, this 0 and this 0 is not significant. Okay, so number of significant digits will be these things only, that is 3, 4 and 5. Okay, so only these numbers are significant, so we have 3 significant figures. Okay, now you should not count this 0 and this 0. Okay, they are not significant. Now next one, all the zeros to the right of a decimal point and to the right of a non-zero digit are significant. Okay, so all the zeros to right of decimal point. Now you see this 40.00. Okay, In this thing, if you see it, they say it has 4 significant figures. Okay, why? Because the rule, you see all the zeros to the right of decimal point, so the number of significant figures will be 1, 2, 3 and then 4. Okay, so it has 4 significant figures. Okay, next one. Okay, now we see next one here, this one. Okay, this example 0.030400 has 5 significant figures. How? Because let's see this now rule here, all zeros to a right of decimal point and right of non-zero digit are significant. Okay, so we know this rule. Okay, from that we ignore this 0 and this 0, you must ignore it. Okay, and then to count significant digits we can take 3, 0, 4 and 00. Okay, so this has meaning here. Okay, 3, 0 then 4, 0, 0. Okay, it has significant here, so we say it has 5 significant figures. Okay, let's go to 7th point now. The 7th point, you can see the number of significant figures does not depend on the system of units used. Okay, so 1.53 centimeters, 0.135 meters, 0.0000153 kilometers all have 3 significant figures. Okay, so you can see that this one, okay, 1, 2, 3 significant digits in this, and ignore these 2, so you'll have this one and this one. It has 3 significant digits here also, and here after this zeros and this 0 you should ignore. No, so 1, 2, 3. Okay, so you can express in any way. You can say centimeter, meter or kilometer, but anyway the number of significant digits will be same only. Okay, let's go to note 1 here. Multiplying or dividing factors which are neither rounded numbers nor numbers representing measured values are exact, and they have infinite number of significant figures as per the situation. For example, circumference of circle S is equal to 2 pi r. Here the factor 2 is the exact number. It can be written as 2.0, 2.00 or 2.000 as required. So when you see this thing, this formula here, S is equal to 2 pi r, in this 2 is no. Okay, it can have infinite number of significant figures is saying. Okay, depends on situation. Now let's go to note 2 now. So let's go to note 2. The power of 10 is irrelevant to the determination of significant figures. Okay, so we don't care about the power of 10 for calculation of significant figures. For example, 5.70 centimeters, 70 meters is equal to 5.70 in 10 power 2 centimeter is equal to 5.70 in 10 power 3 millimeter. That's equal to 5.70 in 10 power minus 3 kilometers. Okay, in each case the number of significant figures is 3. Okay, so the power of 10 is not to be counted while taking the significant figures.